Welcome to the Friday STEM series organized by IISER Pune. I am Anuprita More. I am from IUCA. This institute conducts research in astronomy and astrophysics, and I'm one of the scientists here. So today I'm going to tell you about National Space Day. Welcome everyone. In this past week, we have been celebrating National Space Day. This is celebrated on the 23rd August 2026. And so showing a snapshot from the website. If you are interested, you can go to this website, which is linked here, nationalspaceday.space. And if you go there, then you can listen to some very interesting talks on celebration of the National Space Day and what we plan to do in the future in the field of the space exploration and so on. So today I'm going to take you on this journey to understand why we are celebrating the National Space Day, its importance, and what all we have achieved until so far. So let me begin with something that everyone is familiar with. I hope you can see some part of this image. And what we are seeing here is our own solar system. And I've hidden some names here, and I hope you can guess the names of these various planets. These are all aligned as per their order in the orbit from the sun. So what we have in the top are the names of these planets. So starting from Mercury to Venus, Earth, Mars, followed by Jupiter, Saturn, Uranus, Neptune. And Pluto is also shown here, but as you know, it's no longer a planet. It's called a dwarf planet. So all the planets which are before Mars, they are called inner planets. And the ones which are beyond Mars, from Jupiter onwards, these are called the outer planets. In addition to the planets in our solar system, which go around the sun, there are other kinds of objects that you can also see. Can you think of some names? Can you think of what kind of objects we see? I'm sure you are familiar with them. I'm sure you have seen images of some of those kind of objects. So let me just show those types of different objects that we see. So firstly, we have asteroids, as you can see, which is marked over here. Closer to the between Mars and Jupiter, we have a belt of asteroids. So these are some rocky objects which are also going around the sun. And we have another belt of these asteroids and other kinds of objects which are very close to Pluto. This is called the Kuiper belt object. So other than the asteroids, we also have meteoroids. You must have heard of shooting stars. These are essentially meteoroids which come very close to Earth. They come into the Earth's atmosphere. That's when it's called a meteor. We talk about meteor showers. So we see these meteors falling on the Earth, and when they fall on the Earth, if they survive the journey to reach the surface of the Earth, then these are called meteoroids. And other than that, we also see something like comets. These are objects which are just passing by, flying by in our solar system. Some of them are repeating, and we can see them every few decades or so. One of the famous ones is the Halley's Comet. Either you or your parents have seen that comet coming into our solar system. We can see it with our naked eyes. So there are lots of interesting objects in our solar system. And I would like to talk about just a few of them because they hold special importance. So let me start with our own very nearby, the closest object, celestial object to us, Earth, is this particular object. I hope you can guess. I hope everyone's seen this image. This is our own very own natural satellite. It's called the Moon. So I would like to ask you, what all things do you know about our moon? Have you looked at the moon? Do you know whether you can see the moon in the daytime or in the nighttime? some people think it comes only in the night time, but that's not the case. You can see the moon even also in the daytime. And so what are the other things that you know about moon? Like how heavy it is, how whether it is heavier than Earth or it is less than the mass is less than that of Earth, and if it is less heavier than Earth, then will it have more gravity or less gravity compared to Earth? Uh, what else you can think of? For example, how many days does it take for the moon to go around Earth? And how big is the size of the moon? So there are lots of these questions, and I'm sure you know some of the answers. So let me just some of the facts that could be, some of them you might already know, but some of them could be interesting. So for example, everyone knows that this is our only natural satellite, and the moon takes about 27 days to go around Earth. Moon has no atmosphere, okay? Unlike Earth, Moon has no atmosphere at all. And so, in fact, because of this, anything that happens on the moon's surface can last for millions of years. So, in fact, even the footprints of the astronauts that have been on the moon, they can still be visible. They will be still visible for millions of years. And in fact, the craters that you see on the moon, they are these are these sort of pits that are formed on the moon. They are because of the different collisions happening because of asteroids or meteors or any other celestial objects. And those are the impact that you see on the surface of the moon, and we are seeing them still just because there is no atmosphere, there is no wind, no water flowing, nothing to erase those sort of marks that are left by these various events. There are various other facts. You maybe heard of tides that are happening in the oceans on Earth, high tides and low tides. These are because of the moon. And the distance of the moon from Earth is around 3,80,000 kilometers. A very interesting fact is that nowadays we can measure these distances very accurately, but thousands of years ago, people could get an estimate of this kind of distance just by looking at the effect of the lunar eclipse. So, do you know what happens in a lunar eclipse? In a lunar eclipse, we have the Earth, which goes in between the sun and the moon, and the Earth's shadow falls on the moon. And you can imagine that as the lunar eclipse begins, one edge of the Earth shadow just starts falling on the moon. And then as it keeps progressing, at some point, the other edge of the shadow, the other edge of the Earth's shadow hits the moon, and it passes. And so if you look at the time it takes for Earth's shadow to move across the moon, that basically tells you what is the size of the Earth itself, right? And you can also calculate how much time it takes for this Earth shadow to move across the moon. So you know how much time it takes, and you can see how large the Earth is. Say it has some size, okay, and now you have that information, and you can compare that information with another distance estimate and another time estimate, which is how much time it takes for the moon to complete one revolution around Earth. So you have two time estimates and two distance estimates, and with the help of that, you can find out how far away the moon is uh, in the units of the size of the Earth itself. So with using this method, people had computed that it takes the distance of the moon must be something like 60 Earth radii, meaning given the radius of the Earth, it must be 60 times farther than that. So this is a very interesting thing, and we also know that the moon is much smaller than Earth, and as a result, the gravitational force it exerts on anything else is also much weaker compared to Earth. Another well-known fact is that humans have landed on Earth the first time in 1969. And I don't know how many people know this, but it's found that the moon is actually moving away from us at a very small speed, but it's moving away from us. It is receding from Earth. This was confirmed by some experiments that were done by putting a reflector on the surface of the moon and sending laser light from here, from Earth to the moon's surface, and measuring the time it takes for the light to come back. With this kind of measurements, which are then repeated over several years and decades, we have found that indeed moon is moving away from the Earth. And one last thing, I think, again, this is a very well-known fact, which is that we always see the same side of the moon. And this is because as they say, that the moon is tidally locked with Earth, which means that the number of days it takes for the moon to go around the Earth is the same time it takes for it to rotate. And so it's always facing the same, the same side is always facing the Earth. So next, let me talk about another nearby celestial object. And what do you think this is? This is the next neighboring planet called Mars. And as you can see, it's very red in color. And the main reason for it to appear so reddish is because there is a lot of presence of iron oxide on the surface of Mars. And this results into this reddish hue that we can see. There are, again, very many interesting facts about Mars. This is the fourth planet from the sun. It's also smaller than Earth, so obviously then its gravitational force is also much lesser. The name that was given to this planet, Mars, is after the Roman god of war. And there are some other interesting facts about Mars that makes it special. For example, it has the tallest volcano in the solar system, which is called the Olympus Mons. It has the largest visible impact crater. It also has lots of like valleys and canyons, which are really huge and large. There are also ice caps in the polar regions, which are humongous. Yeah, a few more interesting things. The average day on Mars is very similar to that of Earth, so roughly 24 hours. But the Martian year is much, much longer compared to the Earth year. And yes, you can also see some other interesting facts which are shown here. And other than that, like Earth has only one natural satellite, but Mars instead has two of them. And I'm showing images of these two different satellites. Now, so the name of the two satellites is Phobos and Deimos. Phobos is the slightly larger satellite, and Deimos is much smaller than that. And you can see that for comparison, they've also shown the picture of the planet Mars here. One very peculiar thing that stands out when you look at these pictures is that the Phobos and Deimos, they have very odd shape. They are not spherical looking. Most of the planets that we see, and in fact our own moon, it's spherical. And the question is why? Why Phobos and Deimos? What's so special about them? Why do they have this odd shape? So if you look at the sizes of these satellites, then you will see that they are essentially a few tens of kilometers in size. So these are extremely small, much, much smaller than Moon. And so these, because they are so small and their gravity is so weak that they cannot, the gravitational force cannot sphericalize, so to say. It cannot turn that object into a spherical object. It's not exerting equal amount of force in all directions to be able to compress it into a spherical object. So any object which is much less in mass, it cannot create that kind of spherical shape. And so these objects have their own shape from whatever processes they were created from, and so that's the reason they look so odd. Okay, yeah, here I just wanted to share some comparison between the distances between Earth and Moon versus Earth and Mars. So as I mentioned, Moon is very very close to us. It's given its distance. If we send the light from here to Moon and back, it takes only about 2.5 seconds. So just a couple of seconds essentially. And as opposed to that, Mars is few tenths of or few hundreds of million kilometers away. And as a result, it can take a few minutes to few tenths of minutes for light to go and come back. One interesting thing to note is that the time that is mentioned here is it varies from few minutes to few tenths of minutes, and that's simply because the distance between Earth and Mars, it keeps varying depending on where they are in their own orbits around the sun. This image is obviously not up to the scale, so these distances are, you cannot compare the relative distances here. You can just look at the numbers and compare them. All right, so let me now tell you about ISRO, because we are here celebrating the National Space Day. It's very obvious that we would like to first hear and learn something about ISRO. So ISRO is Indian Space Research Organization. It was formed in 1969. It is the National Space Agency of India. It's located in Bengaluru, in Karnataka. And the main role of ISRO is to perform space-based operations, space exploration, maintain international space cooperation, meaning develop policies and formal understandings between multiple countries such that we can all work together in the same direction of bringing more advancement in the space exploration, and then development of space technologies. So basically, ISRO's role is in everything, each and everything to do with space exploration, space technology, and advancement. So I wanted to also talk a few other things that ISRO does, which plays a very important role. So one of the tasks that it does is launches and maintains different kinds of satellites. So I've shown here 3 different kinds of satellites that you may have heard of or have some idea of, but let's hear about it in some detail. So one kind of satellite that they launch and maintain falls into the category of imaging. And when we say imaging, it means taking images and data in using different these sensors and so on. So for example, the one kind of satellite is looking at weather information. Like you hear in the news everywhere about the weather in all over the globe, what kind of weather you are seeing, the status of the typhoons and tsunami and all that kind of information. And there are other kinds of imaging data that is gathered, for example, environmental monitoring. So for example, you can look at the air quality across different regions. So for example, here I'm showing an image of the air quality across India itself. And you could also be looking at the quality of the soil or water and so on. The other kind of image information that one can gather is called terrain mapping. And that you can get an idea of the altitude levels as you go from one region to another region. So going from the sea level to some plateaus to mountains and so on. So that's the imaging kind of satellites. Then there are the satellites which deal with communications. I'm sure everyone has heard of, televisions and radio and mobile phones. These depend on communication satellites. And the way the communication satellites work is that you have an antenna which is sending some signal, some information to the satellite, and then the satellite passes on that information to another receiver antenna somewhere else on the earth. And so this way we can share information, we can exchange information using these communication satellites. And the third kind of satellite they deal with, it's called remote sensing. Within the remote sensing satellite, there are two categories. One is the passive remote sensing, the other is active remote sensing. And in the passive category, it's essentially like doing photography or looking at infrared images, which are based on the light that is either emitted by the object itself, or it is some ambient light, for example, some sunlight that is falling on that object and that is received by the satellite. So as you can see here in the bottom right image, in the top half, you can see is the example of the passive remote sensing, where there is some ambient sunlight which is falling on the object, and the rays get reflected and received by the satellite, and this information is then passed on to the receiver antenna somewhere on Earth. And in the case of active remote sensing, what happens is that the satellite itself sends some signals to the object of interest. The signals are reflected back and received by the satellite, and then this information is then passed on again to the receiver antenna somewhere on Earth. So this is called active sensing. So some well-known examples of this are radar or LIDAR. LIDAR is the one where they make use of light for sending and receiving, reflecting off. Yeah, these kind of remote sensing technology is usually used for exploring or understanding regions which are dangerous to reach or they are difficult to reach. For example, either it could be the areas like different volcanoes or some very dangerous valleys and canyons, or looking at the ocean information, what is underneath several hundred feet down on the bottom of the sea. And understanding the landscape within the ocean itself. So yeah, so these are different kinds of satellites which allow us to learn a lot with the help of this kind of exploration. So ISRO has been carrying out many missions. So in fact, they have conducted more than 100 spacecraft missions and more than 100 launch missions. There are different kinds of missions that they undertake. I'll just give example of each of these different types. Within the field of astronomy, there is AstroSat, which was launched by ISRO. It's mainly for studying distant quasars and galaxies and nearby stars, different kinds of stars within our own galaxy. And then there is the solar kind of mission where, for example, Aditya L1, this was an instrument that was launched with the help of ISRO, and it was placed in some place very close to sun, somewhere between sun and earth. And this was mainly to study the star, study our sun itself. and as well as the atmosphere or the nearby environment in the vicinity of the sun. And this was the this project was led by a scientist here at IUCA. So, and then there are other missions like studying the Earth itself. So this is called ISRO. This is a joint venture between NASA and ISRO. This is again just to explore the Earth itself. And then when it comes to lunar missions, I'm sure everyone's heard of Chandrayaan, and we'll hear more about it as well in this talk. And then there's also the human space flights. This is the essentially the future sort of um, 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 projects or the different missions that are being planned for human space flight, and this is called Gaganyaan. And this is right now in planning. There's plan to first have a few of the uncrewed unmanned missions, so that we can do perform various tests and see how well things work. And after that, they will be actually sending people in the space to perform various experiments. So these will be the Gaganyaan will be the completely um, um, managed and developed everything within India. Okay, so let me say a few words about the different launch vehicles that are used by ISRO. Like in the various news, you must have heard about PSLV or GSLV or LMV, these kind of acronyms which are used. And so I would like to say a few words about these launch vehicles which are used for launching the different satellites. So here's an image of the PSLV. So PSLV stands for Polar Satellite Launch Vehicle. The PSLV, so it is named so because the satellites, they are launched in a polar orbit. So going basically going from one pole to another pole. Um, and these kind of satellites, they basically scan the entire Earth. So example like weather satellite could be an example of this. So for this PSLV, the structure of this kind of launch vehicle is as follows. It has these 4 stages of fuel. So starting from the bottom, you have the first stage, then the second and third and fourth, as you can see in this image. And the top part is where you place the satellite, or what is called the payload. That's where all the science experiments, all the instruments with which you can do the science experiments, or a satellite is stored in that top part. And these PSLV kind of launch vehicles, they are very reliable, and they have had a high success rate. So you can easily identify this kind of launch vehicle because they have very clearly these 4 stages, or 4 stages or 4 kinds of different, like different fuels which are used. And these kind of launch vehicles are good for smaller payloads, satellites which are medium to small to medium size satellites. It's a cost effective way to launch satellites into space. It's a reliable and very cost effective way. So this kind of launch vehicles have been used for launching multiple satellites. The next kind of launch vehicle they have been using is called the geosynchronous satellite launch vehicle, GSLV. And it's distinct from the PSLV in the sense that it has one solid. The first stage is solid fuel, followed by the second one, which has liquid fuel. And the third stage has cryogenic fuel that is made use of. So what we mean by cryogenic is that the fuel that is used, it is maintained at very low temperatures. So it's cooled down. And this kind of cryogenic fuel is much more powerful, or it offers much more thrust, and is usually used for launching much bigger, much heavier satellites, or for satellites, or any explorations that are to be done for going into much farther distances or much higher orbits around the Earth. And so this is one of the latest technology, and the latest in the series after GSLV are called LMVs. Yeah, so some of the more recent explorations or projects that you will see, they are called LMVs. So let me talk about Chandrayaan-1. So this was the first mission for towards the to the moon, first Indian mission to the moon, and this was launched in 2008. Um, the mission life was supposed to be around 2 years or something, but it managed to perform most of its experiments and achieve a lot of science goals within its time span of 300 days or so, and after which we lost contact. But yet this mission was extremely successful, as this was our first mission, and the idea behind this mission was to send an orbiter around the moon. This mission was also unique in the sense that it was managed within very limited expenses, limited means, and yet it managed to perform all the important science experiments and so on. So the kind of technique that was used is shown here in the bottom right, where this satellite was launched in these multiple steps, first orbiting around the Earth, where in these various steps there was a push given to the satellite every as it goes from one orbit to another orbit, as such that it keeps reaching to higher and higher distances, and at some point then it goes farther enough that it enters the what they call the lunar transfer trajectory, and as it enters in that space, where it is captured by moon, then again there is some push given through these engines, that these orbits are lowered in gradual steps, and then it finally achieved the intended distance from the moon, which was about 100 kilometers or so. And so then it continued to perform these experiments, and the main scientific objective for this mission was to prepare this three-dimensional atlas of the lunar surface itself, and also make an image of the chemical signatures or the chemical composition of the lunar surface. And on this orbiter, which was going around Earth, there were about 11 payloads from many different countries. So not just from India, but from many other countries, like from the European Space Agency, from the US, from Bulgaria, and so on. And there were these a few. So, for example, the Indian payload, which is called the terrain mapping camera, that managed to capture high resolution images of the moon itself, and that helped in deciding or getting an understanding of which are the good regions for landing for future missions and so on. And there was within the Indian scientific payloads, there was this moon impact probe, which was a very crucial probe. The idea of that probe, as the name says, was to crash land this particular probe, so that we can learn something about the soil where this is being crash landed, and get an idea of the composition of the soil and so on. And in addition to the moon impact probe, there was also the moon mineralogy mapper called M3, which was from the US. Together, these two payloads, they helped us essentially discover water on moon. And here are the images. So what you are looking at on the left and the right are the images of the south pole and the north pole of the moon, and the blue features that are highlighted, those are the regions where you can see the frozen water or the ice that's there present on the moon. So these are the scientific results from the first Chandrayaan 1 mission, which is extremely successful. Here on this slide, I'm showing the picture that was taken of Earth from Chandrayaan 1. And I would also like to highlight some of the other, important things that were achieved because of Chandrayaan 1. For example, there were new technologies that were developed within India to be able to conduct this mission successfully. So, for instance, the Indian Deep Space Network was installed and set up, which helps to track and communicate with the spacecrafts, not the Chandrayaan 1, not just the Chandrayaan 1, but also this can be extremely useful for future interplanetary missions. Then there's also the Indian Space Science Data Center, which serves the purpose of processing and analyzing and storing or archiving of all the scientific data that is gathered during these missions. So we basically developed these technologies and these resources, which were not only useful for Chandrayaan 1, but then also for the future space missions that ISRO had taken up. Plus, with the help of Chandrayaan 1, as you saw, the payloads were not just from India, but they were also from other countries. So this Chandrayaan 1 mission, it helped other countries as well to conduct scientific experiments without having to worry or design their or set up their own resources for launching these satellites or launching payloads. And plus the technique that was used by Chandrayaan 1 to be able to reach the moon without without spending too many resources or a lot of money. This kind of technique was then also used by other countries like South Korea for their own lunar mission. All right, so next I would like to talk about the subsequent mission to the moon, which was called Chandrayaan 2. And as you can see from this picture, that this particular launch vehicle that was used is the GSLV launch vehicle. And so the idea for this particular mission was that it was not just going to go to the moon and orbit around it, but so it had the orbit, it had one component where you had the orbiter. So there would be something that will go around the moon for doing different kinds of analysis, but there was also the lander and the rover. So the lander is called Vikram, and the rover, which will actually move around, which will, after the landing, the rover will move around in the vicinity and again conduct some experiments. So the launch of Chandrayaan 2 was around in September, planned to be around in September 2019. Yeah, and as I was mentioning that it has this orbiter, lander, and rover. So the purpose of the orbiter was to take high resolution imaging as well as terrain mapping of the lunar surface. Plus, it was also designed to, there were certain payloads on the orbiter which were designed to study the exosphere of the moon. So even though there's not a huge, there's not much of an atmosphere around moon, there are some gases in some, like small quantities which form the exosphere around the moon. And so there were plans to study the composition of this exosphere around the moon. Plus, you can also study the solar corona, which is the outer layer of the sun itself. And so there were payloads on this orbiter, which was to study the sun as well, even though this mission is for moon, but you can still study the sun And so you can see how clever the scientists are, when they are designing these experiments. They want to make sure that they make the most of the instruments that are set up and sent during these missions. So the job of the lander, the Vikram lander, was to study the seismic activity. Similar to how we have earthquakes, there can be moonquakes. So one of the payloads was designed to look at this seismic activity, to study the properties of the moonquakes that could be happening. And there were other things like studying the temperature variations to understand the thermal properties, and then also things like measuring distances from the lunar surface to the lunar satellites. This kind of information can be useful for various purposes, for future missions, for sending future missions, future satellites, and so on. And the other thing was, as I mentioned, the Pragyan rover, and its purpose was to basically look at the site around the lander, wherever the lander will do the landing, to explore the soil and to study the abundance of different elements that we find in our periodic table, right? To understand the chemical composition of the soil and so on. So here in this slide, I'm showing a quick comparison between the Chandrayaan 1 and Chandrayaan 2. And you can see on the left hand side, you can see going from the bottom, the Chandrayaan 1 was a PSLV, whereas Chandrayaan 2 was GSLV. The job of Chandrayaan 1 was to basically make a map, whereas for Chandrayaan 2, the idea was to do further detail exploration of the lunar surface and the lunar environment and so on. There were, like a dozen or so payloads on both of these missions. Chandrayaan 1 was only the orbiter, whereas Chandrayaan 2 had orbiter, lander, and the rover. So this mission was launched in 2019, and the orbiter was successfully placed in the orbit around the moon, and the lander was, as it was descending, it reached very close to the surface of the moon, but in the just like very last few minutes, there was some software issue that arose and some technical problem that arose, because of which, instead of performing a soft landing where it will just land gently on the surface of the moon, it unfortunately crashed, and because of which the subsequent part, which the lander and the rover was going to achieve, that could not be done. But the orbiter was very successful, and it did manage to perform several experiments using Chandrayaan 2, and it allowed us to learn a lot of things about the moon itself. So the next thing is Chandrayaan 3, and this is again very remarkable achievement that India made with this particular mission. So this was launched in 2023. The kind of payloads it had were very similar to Chandrayaan 2. It had the same kind of orbiter, lander, and a rover with similar goals. And so this time around, it managed to do the soft landing, which happened on 23rd August 2023. And this is the main reason why we are celebrating this National Space Day, because of the success that we managed to achieve with this Chandrayaan 3 mission. And after achieving this soft landing, the India became the first country to land near the south pole of the moon, and it became the fourth country to perform soft lunar landing. So some people ask, why did India land on the south pole of the moon? So the south pole of the moon is it comprises of regions which are permanently shadowed from the sun's direct light, and as a result, they can contain frozen water. So if you may if you may remember, from Chandrayaan-1, we found the presence of the water. And then obviously with Chandrayaan-2 and the other missions also, they studied the amount of water and so on. But this was the first time with the help of Chandrayaan-3 that we managed to uh, explore the south pole of the moon. And since that has a lot of frozen water, this can be very important to understand its properties, thermal properties, like temperature variations and everything, because this can be very useful to for us in the future if we want to use this water. It is extremely important for human survival. It can be important for oxygen production, and also it can be used as a fuel. So if you remember, I talked about this cryogenic fuel that is used in this in the GSLV, the geosynchronous launch vehicle. The cryogenic fuel that is used, it comprises of hydrogen and oxygen. So this kind of I mean, having found the water can be extremely useful because it can be used as fuel as well. The scientific goals of Chandrayaan-3 were to conduct and observe observing experiments on the materials available on the lunar surface, basically to better understand the composition of the moon, chemical composition, and so on. And yeah, it did manage to achieve a lot of the intended goals with the help of this mission. So next, I would like to talk about even more ambitious um, plans that India had, which was to study Mars. So our first mission to Mars, it's called MOM, Mars Orbiter Mission. So just like the Chandrayaan-1, which was only an orbiter, this is also just an orbiter, which means it will be the goal would be simply to send this satellite which will go around Mars. And like as with any initial exploration, you want to basically get a good understanding of what is the environment, what is the terrain, what is the chemical composition on the surface of the Mars, and so on. So this was the idea behind launching the Mars orbiter mission, is firstly to develop the all the necessary technology for us to go from Earth to a distant planet. All the technology that is required to achieve that, including the communication, power, energy requirements, all the software development, and lots of other things that are required for achieving this. So it is to stimulate this kind of development of technologies. Plus, if the mission is successful, we can study the atmosphere around Mars. We can explore the surface of the Mars by taking these imaging of different kinds, and even having the satellite around Mars can even still explore and study the effect of sun's different ejecta that are received, for example, the solar wind and the solar radiation. What is its impact on Mars? Plus, if you remember, I talked about the two satellites that are going around Mars called Phobos and Deimos. This mission was also meant to study Phobos and Deimos because it's very hard to study them otherwise because they are so small. And if we have our own satellite which is going around Mars, then we have much closer view of these natural satellites of Mars, and this is a great opportunity to study them as well. So there were these dimensional goals that the MOM mission had. And this mission was launched in 2013, and it was extremely successful. Right in our first attempt, we managed to do almost everything that we intended to do. And this mission was so successful that it also won the Space Pioneer Award in the year 2015 from the US. as you know, ISRO managed to do this successfully in its first attempt. And so after this, tasting this great success of this first mission to Mars, the next one that is planned is called the Mars Landing Mission, MLM. And there is a lot of advancement happening in the development of this mission. The plan is to launch this sometime in 2030 or 2031. And in this mission, they plan to have a rover and a helicopter to explore the surface of Mars in much more detail. On the right-hand side, you can see the various payloads that are expected to be on this mission, on the satellite, which are which are the goals for these kind of payloads is basically to get much deeper understanding of the chemical composition and looking for any signatures of life on Mars. So these are called like biosignatures and so on, and also to understand the dust properties and many other interesting things, including obviously, you know, searching for the presence of water, and which is extremely important for life. And so yeah, this is something that is in planning. So with this, I come to the end of my talk, and I would like to emphasize again that it's great that we are celebrating this National Space Day. The reason why we are celebrating this on 23rd August is it is to commemorate the first successful soft landing on the moon by India. And it reminds us that India is now on the global map of nations which are executing advanced space missions. And the missions that we've been conducting so far, they showcase that we are capable of these very high-end technology. And not to forget that this is a celebration of, you know, all the scientists and engineers and technicians who have worked non-stop and dedicated their lives for making these missions possible. And celebrating this National Space Day also serves as an inspiration to the future generations. With this, they can be inspired to participate in more and more STEM activities, space research, technology, and innovation. So I hope that you were also inspired by what all you learned from today's talk. And if you're interested to know furthermore, get more in-depth knowledge of what all is being planned, then you can visit this website, which is shown here at the top. And you can hear more from the experts who are actually working in this field. Yeah, and that's all from me from today. Thank you so much for listening.